All right, in the last lesson, we talked about vertical parabolas, and we talked about how the vertex of your parabola is always equidistant from the focus, which is a point, and a directrix, which is a line. And so the distance from the vertex to the focus gives you your p-value. You could also do directrix to focus. That would be the same distance. The important thing is it is signed. So when your p-value is positive, your parabola is opening up. When your p-value is negative, that means it's opening down. That means your focus is here. And here your focus is above. And so with our horizontal parabolas, it's very similar, only now our directrix is a vertical line and our p-value is going to be a horizontal distance. And so here, a positive p-value is going to open to the right. A negative p-value is going to open to the left. The other significant difference is for a vertical parabola, your axis of symmetry was always x equals whatever the x-coordinate of the vertex was, because it was a vertical line. Here, it's going to be y equals, that's the axis of symmetry, whatever the y-coordinate of the vertex is, because it's a horizontal line. Similarly, your directrix is going to be x equals an equation. Here, your directrix will be y equals an equation. So it's like everything is opposite, including the equations. And so here, our y minus k is on the left, and then our x minus h is being squared on the right. Here, x minus h is on the left, and our y minus k is on the right being squared, but we still have the same a value. And so if I just give you an equation, if the y is being squared, you know it's going to be a sideways parabola. If the x is being squared, that's what we're used to seeing from our quadratics unit. So you're going to see a normal looking vertical parabola. We've never seen y being squared. We've never seen sideways parabolas. And so that's how you can keep those straight. And so down here is where we wrote the axis of symmetry is x equals. Here our axis of symmetry is y equals. If a is positive or p, remember a is always equal to 1 over 4p. So if a is positive, you have a happy, smiling parabola. If a is negative, it's sad. For horizontal, it's facing right if a is positive, facing left if a is negative. And then our focal diameter is still going to be given by the absolute value of 4p. And so here is our focal diameter, and then here is our focal diameter. Okay, and so let's jump into some examples. Okay, so for this first one, it's a horizontal parabola facing to the left. And so immediately I know I'm going to have my x minus h on the left, and I'm going to have my y minus k being squared on the right. I can see that the vertex is 0, 0. And then the p-value is going left, and so left 1 would be negative 1. And so that means a equals 1 over 4 times p, which is negative 1, would give us negative 1/4. And so remember, a is what's in the equation, p is what you see from the graph. And so now we can write our final equation. Since it's x minus 0, we're just going to write x. And then our a is negative 1/4. And then we're going to have y minus 0, so we're just going to write y squared. No parentheses when it's 0. Okay, this next one is a vertical parabola. So we're going to go back to y being on the left. Y minus your y equals a x minus your h. X is being squared. I can see that the vertex is 5, 7, 5 for the x, 7 for the y. And then I can see the p-value from directrix to vertex, or to the focus if you want to draw it in, is positive 2. And so my a value will be 1 over 4 times 2, which is 1/8. Okay, so we have 1/8 here. We have a p-value of 2 and a vertex of 5, 7. So now we can fill in this equation. Y minus the y equals a x minus the x squared. Okay, for this next example, they're giving us the equation. I see x is on the left and y is being squared on the right. And so I know this is going to be a horizontal parabola. And then I see that my a value is negative, so I know it's going to face to the left. It helps me to kind of sketch this out. And so let's pick out the vertex. X is 2, y is -5. No matter where they are, x is always with x, y is always with y, and take the opposite. And then here from the equation, remember a is always what's in the equation. And so a is -1/8, put the negative in the numerator. And so that means 1 over 4p is equal to -1 over 8. We can cross multiply this, so 4p times -1 is -4p. And then 1 times the 8 is just 8. Divide both sides by -4. We get p equals -2. Okay, and so we can start making our graph. We have a vertex at 2, -5. And then the p-value is -2. And because this is horizontal, usually for vertical, we would go down 2 to get to the focus. But this time, we want to go left 2 to get to our focus. Negative for horizontal is to the left. And then our directrix would be the opposite direction. Okay, so there's our directrix. Here's our focus. So the focus is 0, -5. The directrix is x equals 4. A vertical line is always x equals. And then the axis of symmetry is going to go right through the vertex, kind of visualizing what this is looking like. Our axis of symmetry would be y equals this -5. Should always match the y coordinate of your vertex. Okay, to find the length of the focal diameter, that's absolute value of 4p, which we found to be -2. So absolute value of -8, which is 8. So this is going to be a very wide parabola. Okay, and so because the focal diameter is 8, that means the radius is 4. So go to your focus and go up 4 units, and then down 4 units. Okay, and so kind of like that. And so this time our domain isn't -infinity to a positive infinity. That would be our range. It's going up forever and down forever. And so this time our range for these will be -infinity to positive infinity. And then our domain goes from -infinity and stops here at the vertex, which is 2. So -infinity to +2 with a bracket, because we do equal that point. Infinities never get brackets. Okay, next, once again, we see that y is being squared. So we know this is horizontal. And I see that my a value is -1, so that means we are going to have a left-facing parabola. The x-coordinate is 4 for the vertex. The y-coordinate would be -6. Go ahead and graph that. And then that tells me my axis of symmetry will be y equals -6. Okay, and so because we know the a value is -1, invisible 1 there, that means 1/4p is equal to -1. If you like cross multiplying, you can still write that -1/1, and then you can cross multiply 4p times -1, and then 1 times 1. So that would give us -4p equals 1, divide by -4. So p equals -1/4. Okay, and so because this is a horizontal parabola, that negative p value means we go left -1/4 to get to the focus. And then our directrix would be to the right 1/4. Okay, and so to the left 1/4 would put us at 3.75 in the x. And then our y value is still -6. And then the directrix, since we went to the right 0.25, is going to be 4.25 going through the x. You can use mixed numbers or improper fractions, whichever. Now, for the length of the focal diameter, we do absolute value of 4p, which is -1/4. So we get a -1, which would be +1. And so that means we are going to go, since our diameter is 1, that means each radius is 1/2. So go up 1/2, go down 1/2. And we can go through those points to make our parabola. Range is -infinity to +infinity because we're going up forever and down forever as it goes to the left. Our domain is going from -infinity and gets stopped at the vertex, which is 4, with a bracket. Okay, these last two, they're giving us information, and we write the equation, domain and range. So here they're telling us the vertex is -2, 4. And the directrix is x equals -4. So x equals -4 is right here. That means it's a vertical line, which tells me I'm dealing with a horizontal parabola, and the focus would be 2 away as well. So something like that. And so if p is 2, that means a is 1/4p, which is 1/8. And so because this is a horizontal parabola, we're going to have x on the left, x minus the x, equals a, and then y minus the y being squared. And so the vertex was -2, 4, and then we just found the a value to be 1/8. So now when we write our final equation, we're going to see an x plus 2 equals 1/8 y minus 4 squared. Domain is going from this -2 to +infinity. Ooh, with a bracket. We do equal the vertex. And then range -infinity to +infinity. These arrows are going down forever and up forever as they go to the right. right? And so even if they don't give you a graph, still sketch it out so you know what's happening. And so the focus is -3, 4. That's going to be in quadrant 2. 1, 2, 3. 1, 2, 3, 4. And so that is the focus, not the vertex. And then the directrix is x equals 5. X equals 5 is a vertical line. And so once again, this tells me I'm dealing with a horizontal parabola, and I also know it's facing to the left. And so I know it's going to be x on the left, y on the right being squared. And so to find the vertex, remember it's equidistant between the focus and the directrix. And so from -3 to 0 is 3 units, and then we have another 5 units. That's a total of 8 units. And so we need to just go 4 to get the vertex. So that puts the vertex at 1, and then still a y coordinate of 4. Okay, and that's all we need to be able to write our equation, except the p-value. Okay, and so remember, it's always focusing on the focus, so facing the focus back to the directrix. And so this distance from -3 to 1, it's backwards, so p equals -4, going from 1 to -3. And so that means a equals 1 over 4p, which is -4, would give me a -1/16. So -1/16 for the a. Our h is 1, our k is 4. Our h is 1, k is 4. And so when we write our final equation, we're going to have an x minus 1 equals -1/16, y minus 4 squared. Domain, we're going left, so from -infinity, and then we get stopped at x equals 1 with the bracket. And then the range, still -infinity to +infinity, arrow pointing down, arrow pointing up.